Hello everyone, today I will discuss the JEE Main 2024 31st Jan Shift 1 chemistry paper. So let us see this paper. The question number 1 says, given below are two statements. Statement number 1 is noble gases have very high boiling points. Statement number 2 is noble gases are monoatomic gases. They are held together by strong dispersion forces. Because of this, they are liquefied at very low temperature. Hence, they have very high boiling points. Now, we all know that noble gases have very low boiling points and melting points. So, statement number 1 is wrong. I mean, it is incorrect. They have very low boiling points, in fact, melting points too. If we see helium is having a boiling point of just 4 Kelvin, around 4 Kelvin. So it's quite low. And what is the reason behind the low boiling and melting points? The reason is weak dispersion forces or London forces. But it is saying the statement number 2 is saying that they are held together by strong dispersion forces. So no, they are held together by weak dispersion forces. Now this question is NCERT based, the theory given in NCERT book only. So both the statements are incorrect. So both statement 1 and statement 2 are false. So I hope this is clear. Let us move to the next question. The second question is, for the given reaction, choose the correct expression of Kc for the following reaction. Now we know that the law of chemical equilibrium says that the product concentration divided by the reactant concentration raised to the power their stoichiometric coefficients gives you a fixed value, which is Kc, that is equilibrium constant. Now, so going by that, A is the right, that this first option is the correct answer because it is the reactant concentration divided by the product concentrations and raised to their stoichiometric coefficients. Here the coefficients are 1, so A matches. I mean, A is the right answer to this question. I hope this is clear. Let us move to the next question. The next question is, identify the mixture that shows positive deviations from Raoult's law. Let's look through the options. There are 4 options. Now, before we look at the options, we should be knowing what are mixtures which show positive deviations from Raoult's law. Now, we all are aware of the non-ideal solutions, the solutions which do not follow Raoult's law over the entire range of concentration. Now, there are solutions which show positive deviation and negative deviation from the Raoult's law. Now, positive deviations means that the resulting vapor pressure of between the solute and the solvent particles is higher than expected. Why? Because of the weak intermolecular forces of attraction, right? So if we see the 4th option, acetone and carbon disulfide, now this mixture shows positive deviation from Raoult's law. Why? Because there are dipole-dipole interactions among the acetone molecules and CS2, they just break those interactions, so resulting into the weakening of the intermolecular forces of attractions. Hence, this mixture shows positive deviation. If we see 1, 2, and 3, all 3 are the examples for negative deviations. All 3 are the examples for negative deviations, where the resulting interactions are stronger than the individual interactions. If we see chloroform and acetone, there is a possibility of hydrogen bonding, right? So they are the examples of negative deviation, and the answer to this particular question is 4. That is the mixture of acetone and carbon disulfide. All right, let us discuss the next question. The next question is, the compound that is white in color. Now this is very simple question. If you say, you know lead sulfate, PbSO4, that's a white solid, right? So PbSO4 is a white solid. And this is the answer because it says that is white in color. Now, ammonium sulfide, lead iodide, and ammonium arsenomolybdate all are yellow in color, right? This is yellow in color, this is also yellow, and this is also yellow. So the answer to this question is lead sulfate. Quite simple. Let us move to the next question. The next question is, the metals that are employed in the battery industries are Now we know when we study the applications of the transition metals, we know that they find applications in the battery industries, right? We are aware of the primary cells and the secondary cells. There is a dry cell in which we find application of manganese in the form of MnO2 paste, right? So this is used in the dry cell. We already know it. Then there is nickel cadmium cell or nickel cadmium battery. So nickel and cadmium are also used in the battery industries, right? So transition metals find applications in the battery industries. So manganese, nickel, and cadmium, they are used in the battery industry. So if we see B, C, and E, yes, B, C, and E, that is the right answer. All right. Let us move to the next question. The next question is, a species having carbon with sextet of electrons and can act as electrophile is called. Now, this sextet of electrons means 6 electron species. 6 electron species. We know carbocation, right? Now, carbocation, if you see, this is carbocation, and there is a vacant p orbital, right, which is empty. This is trigonal planar, and hence it is having 6 electrons. It is the species with sextet of electrons. So carbocation is the right answer, right? So there are 6 electrons. Let us move to the next question. The next question is, identify the factor from the following that does not affect electrolytic conductance of a solution. Now, electrolytic conductance depends upon, it depends upon the nature of the electrolyte, the size of the ions produced. It depends upon the temperature. Usually, it increases with increase in temperature. Then it depends upon the solvent, right? The nature of the solvent. Also its viscosity. And it depends upon the concentration of the electrolyte, but it does not depend upon the nature of the electrodes used, right? Again, a theory-based question from NCERT only. Okay, so second is the right answer. Let us move to the next question. The next question is, the product C in the below mentioned reaction is, okay, so let us see. This is the substrate molecule. We have the CH3, CH2, CH2Br, and the reagent is alcoholic KOH, and heat is also given, so it is an example of elimination reaction. It is beta elimination, and in beta elimination, it is a kind of E2 elimination, where H and Br, which are anti to each other, there is a dehydrohalogenation. So what do we get? We get alkene of this sort, right? This is the alkene we get. This is A. Now, A upon treatment with HBr. Now, this is an example of electrophilic addition reaction, right? What do we get? It is accompanied by the carbocation formation. So, more stable carbocation will be formed here because that would be 2 degree, and Br minus would attack over there. So, what do we get is this. Then in the next step, it is your KOH aqueous. Now here, OH minus will act as a nucleophile, right? And it is an example of nucleophilic substitution reaction. Br will be substituted by OH, right? So what do we get is this. So this is the final product. This is A, this is P, and this is C. So they are asking you about C. So C is 2. Basically, it is propane 2-ol, right? So it is propane 2-ol. So if you see the option, 4 is the right answer. Okay. Again, a simple reaction, set of reactions. All right. Let us move to the next question. The next question is, given below are 2 statements. One is labeled as assertion A, and the other is labeled as reason R. Now, assertion is alcohols react both as nucleophiles and electrophiles. Now, alcohols react both as nucleophiles and electrophiles. Yes. Now, depending upon the type of bond which is broken, like if you know this. So suppose if we break the bond between O and H, we get alkoxide ion. It is acting as a nucleophile, right? And suppose the bond between carbon and oxygen is broken, what do we get? We get a carbocation, right? So here it is acting as an electrophile. Now, acidity of alcohol can be explained by taking into consideration the nucleophilic nature. And for this, let's say a dehydration of alcohol. So dehydration of alcohol can be explained on the basis of its electrophilic nature. So yes, they react both as nucleophiles and electrophiles. Absolutely correct. Let's see the reason for this. Alcohols react with active metals such as sodium, potassium, and aluminium to yield corresponding alkoxides. Absolutely correct. And liberate hydrogen gas. Yes. So this explains the acidic nature of phenol. So yeah, it is explaining the acidic nature of phenol, but it is not explaining the alcohol acting as electrophile. Though it is explaining it, the nucleophilic nature of it, but it is not explaining anything about its electrophilic nature. So the statement is correct, but this reason is not the correct explanation for the assertion. So both are correct, but R is not the correct explanation of A. So fourth is the right answer. Let us discuss the next question. The next question is the correct sequence of electron gain enthalpy of the elements listed below. All right. Now, for this question, we must be knowing at least two things. We usually know that if we talk about the negative electron gain enthalpy, we know the order. At least this order we know, that chlorine followed by fluorine, then there is sulfur, and there is oxygen, right? The first members, they have lesser negative electron gain enthalpies because of small size, right? So this order we know, right? But this is the order of negative electron gain enthalpy. We also know that noble gases, they have positive electron gain enthalpies, right? And argon being a noble gas, it will definitely have the maximum electron gain enthalpy. So 1 and 4 are eliminated. Now A would definitely go, and we also know that it is chlorine followed by fluorine, then there is bromine, and then iodine. So if we go by that also, so it will be A, then it will be sulfur, because halogens ke baad that there is sulfur, and then it would be bromine, and then fluorine, right? So it would be A, then D, then B, and then C. So second is the right answer. Okay, so please remember this is the order of negative electron gain enthalpies, right? And argon having the positive electron gain enthalpy, followed by sulfur, then there is bromine, and then finally the fluorine. All right, let us discuss the next question. The next question is again the statement type question. Let us see the first statement. The chromate ion is square planar. Now we know that the chromate ion and the permanganate ion, they are tetrahedral, right? So it's square planar. No, it's not square planar, it's tetrahedral. So this is wrong. We know that chromate ion is tetrahedral, right? It's of tetrahedral nature. Dichromates are generally prepared from chromates. Yes, if you see the preparation of potassium dichromate, we start the preparation by from chromite ore, right? Chromite ore, which is FeCr2O4. This, upon reaction with Na2CO3 in the presence of air, what do we get? We get sodium chromate. Yellow colored compound, so sodium chromate. Now this sodium chromate upon acidification gets converted to sodium dichromate, and which upon treatment with for say KCl gives you potassium dichromate. Then yes, the dichromates are generally prepared from chromates. This is true. The green manganate ion is diamagnetic. The green manganate ion, which is K2MnO4, potassium manganate, this is dark green color. Here manganese is in +6 oxidation state because this is MnO42 minus +6, right? +6 oxidation state. +6 means that it is your D1 configuration. And if it is D1 configuration, there is one unpaired electron. So it is saying that it is diamagnetic. No, there is one unpaired electron, which makes it paramagnetic. So this is again wrong. It's not diamagnetic, it's paramagnetic. The next question, dark green colored K2MnO4 disproportionates in neutral or acidic solution. Yes, we know that MnO4 2 minus, for say in the presence of an acid, it disproportionates into permanganate ion, MnO4 minus, and MnO2, right? So we can show it like this, MnO4 2 minus upon, in the presence of an acid, it disproportionates into manganate plus MnO2. And yes, obviously there is water. So it is +7, it is +4. So the same species is getting oxidized as well as reduced. Yes, it disproportionates, absolutely correct. Let us see the next statement. With increasing oxidation number of transition metal, the ionic character of the oxides decreases. Now this is true. This is correct statement. This is a direct statement from NCERT only. Like for example, if you see Mn2O7, right? Mn2O7 is a green covalent oil. So yes, the ionic character decreases with the increase in the oxidation number of the transition metal. For say Mn2O7, that's covalent oil. I mean, it's a green covalent oil. So this is also wrong. No, sorry, this is correct. So B, D, and E are correct. So fourth is the right answer. I hope the question is clear to you. All right, let us discuss the next question. Okay, adsorption principle is used for which of the following purification method? We know chromatography, right? Chromatography is a technique used to separate the components of the mixture and also their purity, testing their purity. And based upon the principle, like it is of two kinds, based upon the principle of adsorption. There is column chromatography, there is thin layer chromatography, and then there is partition chromatography. So chromatography, and to be precise, column chromatography or thin layer chromatography, they are the examples of chromatography based upon the adsorption principle. So adsorption principle is used for which purification method? It is for chromatography. In extraction, we know that it is based upon the principle of solubility. Distillation is when the liquids have significant difference in their boiling points, and sublimation is quite simple, separating the sublimable substances from non-sublimable impurities. So second is the right answer. So let us discuss the next question. The next question is, integrated rate law equation for a first order gas phase reaction is given by this. Okay. So let us take an example that A is giving you B plus C, all right? So let's say that at time t is equal to 0, we are starting with the pressure Pi, it is 0 and 0. At t is equal to T, let's say this is your X, and this is Pi minus X, okay? So the integrated rate law equation for the first order reaction is K is equal to 2.303 upon T log of, initial pressure. Initial pressure is Pi. Now the final pressure, that is Pi minus X. Okay. So we know that what is total pressure? The total pressure is Pi minus X plus X plus X. So we can say it is Pi minus X, right? So if we can find out the value of X from here, the X is PT, the X is Pi minus PT. Now so basically here we have Pi minus X, putting the value of X, what do we get? We get Pi, and for Pi we can write, so this is Pi, and in place of X we can write Pi minus PT, right? So what it will be, Pi minus, it is plus X, right? It is plus X. So this will be PT minus Pi, all right? So putting that value here, it will be twice of Pi minus PT. This is the final expression. So let's see which option matches with this. 2.303 upon this Pi, yes. First is the right answer. I hope this is clear to you. All right, let us move to the next question. The next question is, given below are two statements. One is labeled as assertion and the other is labeled as reason. Assertion is pKa value of phenol is 10 while that of ethanol is 15.9. And reason is ethanol is a stronger acid than phenol. It is contradicting the assertion. So basically, the assertion is true, yes, because we know that phenol is more acidic, so lesser pKa value. Why? Because the phenoxide ion formed after the release of H is resonance stabilized. So an ethanol is stronger acid? No. Phenol is a stronger acid because of this resonance stabilization of the phenoxide ion. So A is true, but R is false. So A is true, but R is false. All right. Let us discuss the next question. Given below are two statements. Statement number one is IUPAC name of this. Okay, let us write it in this form. CH2, 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 C double bond, CH3. So let us find the IUPAC name of this. Right, this is 1, 2, 3, 4, 5, 6, and 7. So what is this? This is 7-hydroxy. Yes, 7-hydroxy hapten 2-one. So 7-hydroxy hapten 2-one. Yes, statement 1 is correct. Statement 2 says 2-oxo-hapten 7-ol. Obviously, you cannot end the name with all. So that's the correct IUPAC name? No, it is not the correct IUPAC name. So statement number 1 is correct. This is the actual IUPAC name of this. So statement 1 is correct, but statement 2 is incorrect. Yes, first is the right answer. Let us move to the next question. The correct statements from the following are: the strength of anionic ligands can be explained by crystal field theory. No, this is incorrect. In fact, this is one of the limitations of CFT, right? Because if you say that why water is a strong field ligand and why OH minus is a weak field ligand, there is no explanation there is no explanation by CFT. Valence bond theory does not give a quantitative interpretation of kinetic stability of coordination compounds. Absolutely correct. Because VBT does not talk about the stability of complexes. So this is correct. The hybridization involved in the formation of this complex is DsP2. Yes, this is absolutely correct because it is a square planar complex. Because this is D8 system, nickel is in +2 oxidation state, and so D8 is 1, 2, 3, 4, 5, 6, 7, 8. And cyanide being a strong field ligand, it will pair up this. So we have one empty D. So DsP2 is absolutely correct. This is correct. The number of possible isomers of this complex is 1. Okay. Now we know that suppose we have this type of complex, MAA whole twice, A2 type complex, where this capital A is your bidentate ligand and this is small a is your monodentate ligand. Then we know that there can be a cis form and there can be a trans form. I told you that if there are 3 such bidentate ligands or even 2, then when they are placed at cis position, there cannot be plane of symmetry because they are always perpendicular, right? So there is no POS. There cannot be POS in the case of cis isomer. In the case of trans isomer, obviously there will be a POS, right? You can say that there will be a slice cut. So there will definitely be a POS. Let me show you. So see, there is a plane of symmetry like this, or slice cut also. So cis isomer is optically active, whereas trans isomer is optically inactive. If it is optically active, there will exist an enantiomeric pair. So it is saying it's 1. No, it's not 1. There will be an enantiomeric pair, right? So this is also wrong. So B and C are correct. So they are asking you the correct statements. B and C are correct. All right. Let us move to the next question. The linear combination of atomic orbitals, or what we call LACO, to form molecular orbitals takes place only when the combining atomic orbitals they have the same energy. Absolutely correct. They should have the same energy and they should have the same symmetry. Why? Because 1s orbital of 1 will overlap with will combine with the, in fact, not overlap, will combine with the 1s of another. So this is absolutely correct. They should have the same energy. They should have the minimum overlapping? No, they should have the maximum overlapping, because if the overlapping is more, there will be more electron density between the nuclei in the molecular orbital. So they should have the minimum overlapping? No, they should have the maximum overlapping. They should have same symmetry? Yes. They should have different symmetries? No, they should not have different symmetries. So A and they are saying takes place. Okay, so A and C are correct. Most appropriate are A and C. So second is the right answer. Okay, let us move to the next question. All right, a question from biomolecules, carbohydrates. Let us see the reactions of glucose. So we know that glucose, let's start with the reactions that we already know. So we know that in the presence of HI, upon prolonged heating, it gives rise to N-hexane. So C will definitely go with third. So third is eliminated. If we see bromine water is a mild oxidizing agent. It will, the CHO part in the glucose will get oxidized to COH, giving rise to gluconic acid. So D goes with 1, D goes with 1. And I think we have already got the answer, 2, because D is matched with 1 only in 2, so that gives us the answer. But let us see the other options. So glucose with HNO3, which is a strong oxidizing agent. Here the CH2OH is also oxidized to COH. That's give you saccharic acid or glucaric acid. And glucose with NaHCO3, it doesn't give a reaction with NaHCO3, because NaHCO3 is, it will react with acids, right? It gives reaction with acids. Now glucose does not dissociate in water. So yes, there is no such reaction with NaHCO3. So A goes with 2, and this gives us the answer, which is 2. All right, let us discuss the next question. Consider the oxides of group 14 elements. These are the oxides. The amphoteric oxides are, okay, we know that CO is neutral. So this cannot be the answer. We know about this GeO2 and GeO, the oxides of germanium. So they are acidic. They are acidic. Right? So again, here we have germanium oxide. This is also wrong. Now SNO2 and PbO2 or PbO, SNO, all these are amphoteric oxides among the oxides of group 14. Apart from them, we have CO2, which is again acidic, right? So acidic oxides, here we have got this, which is acidic. CO is neutral, so we are left with the third option. SNO2 and PbO2, the oxides of tin and lead, they are amphoteric in nature. Let us discuss the next question. Again, the match list 1 with list 2 type question. So here we have the techniques. Here there is an application. So let's start with distillation. Distillation is where the liquids having significant difference in their boiling points can be separated. So example being chloroform and aniline, right? Chloroform and aniline, there is a significant difference. So A goes with 4. So third and fourth, they are eliminated. We have eliminated third and fourth, so A goes with 4. Fractional distillation, separation of crude oil fractions, petrol, diesel, gasoline, right? Yes, so separation of crude oil fractions via fractional distillation. Steam distillation, what is steam distillation? To separate the compounds which are steam volatile, right? They are steam volatile and also immiscible with water. So steam distillation is aniline and water mixture, right? So C goes with 2, C goes with 2, and B goes with, right? B goes with 3. So second is the right answer, right? So see, A goes with 4th, and B, the fraction distillation, separates the crude oil fractions. Then we have C, steam distillation, which will separate the aniline water mixture, and separation of glycerol from spent lye. This will be done by distillation under reduced pressure. Now what happens here? We separate the compounds which have very high boiling points, and they decompose at or below their boiling points. So separation of glycerol from spent lye, it matches with this technique. Okay, so we have got the answer, that is 2. Let us discuss the next question. All right, let us discuss the questions from section B. The first question is molar mass of the salt from NaBr, NaNO3, KIN, CaF2, which does not evolve colored vapors on heating with concentrated H2SO4. All right, then C. This involves a test for bromide, nitrate, and iodide. We know that here, upon reaction with concentrated H2SO4, we get the bromine vapors, right? Bromine vapors, which is yellowish orange. Here we get the, orangish vapors of nitrate. And then here we get the violet vapors of iodine vapors, nitrate vapors. Now in CaF2, when reacts with H2SO4, what do we get? We get calcium sulfate, plus we get the fumes of HF. We get the colorless, in fact, this is colorless. We get the colorless fumes of HF. So no colored vapors. They're the colorless fumes of HF, right? And they're asking you the molar mass. So let us calculate the molar mass. Calcium is 40 and fluorine is 19. So this is 38, which gives you 78 gram per mole. So 78 gram per mole is the answer. That is 78. Okay. I hope this is clear. Let us discuss the next question. The spin-only magnetic moment for this complex is, all right, spin-only magnetic moment. So we know what is the formula? That is n plus root, square root of n plus 2, where n is the number of unpaired electrons. Bohr magneton, right? So let us see this. Nickel is in +2 oxidation state. That means it is D8 system, right? And ammonia being a weak field ligand. So let us see. 6, 7, 8. So we have the 2 unpaired electrons. The n value is 2. What do we get? 2 plus 2. That means we get under root 8, or we can write 2.82 Bohr magneton. But we are supposed to give an answer in this form. Okay, so we can write it. You get 28.2 into 10 to the power minus 1, or to be precise, we can write it approximately 28, right? So 28 into 10 to the power minus 1 Bohr magneton. I hope this is clear to everyone. Let us discuss the next question. Number of moles of methane required to produce 22 grams CO2 gas after combustion is x into 10 to the power minus 2 moles. The value of x is. Okay. So combustion of methane. What do we get? What are the combustion products? CO2 and H2O. What do we get? So basically this is 2 and 2. So 1 mole of methane requiring 2 moles of oxygen in order to form 1 mole of CO2. So 1 mole CO2 from 1 mole methane, right? And 1 mole of CO2 means 44 gram of CO2. But they are asking you about 22 grams. So 22 gram would be formed by obviously half mole of CO2, that is 0.5 mole methane, 0.5 mole of CH4. All right. So they are asking you, but we are supposed to give the answer in this form. So we can write this as 50 into 10 to the power minus 2 moles. So the x value is 50. So 50 is the right answer. Okay. Let us discuss the next question. The product of the following reaction is P. Okay. So the product is P. The number of hydroxyl groups present in the product P is, the first is the reaction with the Grignard reagent. Let us see this reaction. What do we get? Right? Okay. The reaction with Grignard reagent. We know metals are electropositive. We get positive charge here. This will give us carbonine. Then here we can write partial negative, partial positive, right? So what do we get? We get benzene, because H will combine with this. It will attack on this H, right? And also we get CHO and we get ONJBr, right? So And the second step is aqueous NH4Cl. Now, aqueous NH4Cl is just the workup reagent. It will, it is used for workup. And what do we get? We get the reactant back. We get the reactant back. So so our product is benzene. So this is our product, right? The number of hydroxyl groups present in the product is, now here is benzene, there is no hydroxyl group, so the answer is 0. 0 hydroxyl group in product B, that is benzene. Please do not get confused with aqueous NH4Cl, it's just the workup reagent. All right, okay, let us discuss the next question. The number of species from the following in which the central atom uses sp3 hybrid orbitals in its bonding is, okay. Let's select the ones which are very simple. NH3, sp3 hybridization, right? N is sp3 hybridized. Then CO2, C is sp hybridized. H2O, oxygen is sp3 hybridized. CH4, it is again tetrahedral geometry. sp3, carbon is sp3 hybridized. Now BF3, we know B is sp2 hybridized. It is trigonal planar geometry. SO2, SO2 is bench-shaped, trigonal planar geometry. The electronic geometry is trigonal planar. Again, this is sp2. BeCl2, Be is sp. This is linear, so there is sp hybridization. Now we are left with SiO2. Now we know that in most of the cases, SiO2 forms the 3D network solids. We already know from silicates, right? So, and it favors tetrahedral coordination. This silicon, we can show it like this. Again, and this goes again. So we have this silicon, silicon favors tetrahedral coordination. So again, it is sp3. So it is saying where the central atom uses sp3 hybrid orbitals. So 1, 2, 3, 4. 4 such cases. So the answer is 4. Please remember this. This is from silicates. Right? Okay. Let us discuss the next question. Again, a set of reactions. Okay. Now, NaOH and alcohol, this combination gives us alcohol. This is basically alcoholic NaOH, right? So that means product A is an alkene, which is formed by the dehydrohalogenation of this alkyl halide. So what do we get? We get CH2 double bond CH2. This is the elimination product. And in the second case, what do we get? This is aqueous NaOH. That means it is an example of nucleophilic substitution reaction where Br is replaced by OH. So we get ethanol. The total number of hydrogen atoms in product A and product B combined is, so let's see, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 hydrogen atoms in product A and B. All right? So quite a simple question. Let us discuss the next question. Number of alkanes obtained on electrolysis. Okay, we know coal-based electrolysis of a mixture of, we have 2 carboxylate and salts, right? Salts of carboxylic acid. All right. So let's see. Now from here, what do we get? We get CH3 radical, right? And from here, what do we get? We get ethyl free radical, right? We get ethyl free radical. Okay. So now there are 3 possibilities. This is a kind of coupling reaction only. This is a kind of coupling reaction. So 2 methyl radicals can combine with each other to give ethane, right? This type of alkane. These 2 ethyl radicals can combine with itself to give this alkane. Now, and they can combine with each other also in the manner that we get this. So there are 3 such types of alkanes obtained on electrolysis of a mixture of these 2 salts of carboxylic acid. So the answer is 3, right? It is a coupling reaction and it is coal-based electrolysis, right? Okay, let us see the next question. Consider the following reaction at 298 Kelvin this is the reaction. You are given the value of Kp, and what you are given is delta G naught for the reaction is. All right. So there are a lot of calculations involved. The question is based upon just one formula, that is minus RT ln of K equilibrium, right? We can write it minus 2.303 RT log of K. Now minus 2.303, R is 8.314. Since we need the answer in kilojoule, let us divide it by 10 to the power 3. What do we get? Temperature is 298 Kelvin. All right. And log value is 2.47 into 10 to the power minus 29. All right. When you solve it, this will be minus 2.303 into 8.314 upon 10 to the power 3 into 298 into, we know that log of A into B is log of A plus log of B. We also know that log of 10 to the power, we can write it like this, that A to the power B is B log A, right? So log of 2.47, now log of 2 is 0.30 and log of 3 is around 0.47, right? So can we take log of 2.47 around 0.4? Okay, so I'm taking 0.4, and log of 10 to the power minus 29 would be minus 29 log 10, and log 10 is 1, so it is minus 29. And when you solve it, because this minus and this minus will get cancelled, when you solve it, you will get 163.187 something, right? Kilojoules. So delta G naught is, to be precise, that we can round it off to 163. So 163 kilojoule is the answer. Lot of calculations involved, but this is the only formula that we need to use. Let us discuss the next question. The ionization energy of sodium in kilojoule per mole if electromagnetic radiation of wavelength 242 nanometer is just sufficient to ionize sodium atom. It's just sufficient. Okay, so let us find out. We know that E is equal to h nu, which I can write hc by lambda, right? Okay. Now we need the answer in kilojoule per mole, obviously. So what we are supposed to do? We are supposed to multiply it with Avogadro's number, and this will be the answer in joule. We need the answer in kilojoule, so let us divide with 10 to the power 3. Let us put the values. H is 6.626 into 10 to the power minus 34 joules second. What is C? C is 3 into 10 to the power 8 meter per second, right? What is lambda? Lambda is 242 nanometer. Nanometer is 10 to the power minus 9 meter. Then we have Avogadro's number, which is 6.022 into 10 to the power 23, right, per mole. And here we have 10 to the power 3, right? And when you solve it, we will get the answer 494 kilojoule per mole, right? So what is the answer? The answer is 494 kilo. 494. I hope this is clear. Let us discuss the next question. Okay, let us see the last question. 1 Faraday of electricity liberates X into 10 to the power minus 1 gram atom of copper from copper sulfate. X is what? Okay, so let us see the reaction first. Copper sulfate, that means Cu2 plus, will take up 2 mole of electron, getting converted to, it will deposit 2 moles of electron. That means 2 Faraday of electricity will deposit 1 mole of copper. 1 mole of copper. So 1 Faraday will deposit 0.5 mole copper. 0.5 mole copper. Now they are asking you X into 10 to the power minus 1 gram atom. Now gram atom is nothing but mole only. We know that molar mass can also be called gram atomic mass. So gram atom is nothing but mole, right? So 0.5 mole, but we are supposed to give the answer in this form. So we can write it 5 into 10 to the power minus 1. So 5 is the right answer. So X is 5. I hope the question is clear. Okay, thank you.